These are the graphs of the logarithmic functions. The first one is y equals logx. You can see that this graph on the left-hand side heads down, and as it heads down, it actually trails along the y-axis. It gets closer and closer to this y-axis, but it never actually hits it. Hard to believe, but it's true. As it heads up to the right, it crosses the x-axis here at 1, and then it tails off. This graph is the slowest increasing graph that you can get compared to the polynomial functions and the linear functions. Let's compute some values here. Let's say that x is 6. So x is 6 right here, and we're going to find the y value. So at x equals 6, the y number is log, and I'm subbing in the 6 for the x. So on my calculator, I'm working out log of 6, and I got 0.78. And looking at the graph, let's see, here's 1 on the y line. So going across, 0.78, yep, looks like that. Let's go the other way. Now let's pick a y number. So let's pick y to be 1. And I want to find x, so I'm subbing in 1 for y, log x. And I'm going to move the log over the other side to get x by itself. And looking on your calculator, opposite of log, 10 to the power of. So this is 10 to the power of, and this 1 becomes an exponent. So 10 to the power of 1 is 10. X is 10, and y is 1. 1. Yep, that makes sense. Let's take a look at the next graph, which is y equals lnx. You can see it says the same properties. This graph is heading down next to the y-axis. Same thing, gets closer and closer, never meets it. As we go up the graph to the right, it hits the x-axis at 1. And then continues on, and again, because it's a logarithmic graph, it is a very slowly increasing graph. And let's do about the same thing. Let's figure out at x equals 6. Let's figure out what y is. So at x equals 6, y is, and I'm subbing into the equation 6 for the x. So on my calculator, ln of 6, and I'm coming up with 1.79. That's rounded off. So 1.79 going across the y-axis. Here's 1. So that'd be 1.5 right there. 1.79. Yep, that makes sense. And let's figure out at y equals 1 what x is going to be. So I'm subbing in 1 for y. And so 1 is going to equal ln x. At 1, x is, okay, it hits the graph right there. So we're going to expect x to be 2 point something. 2.6, something like that. So let's find out. So I'm moving ln to the other side to get x by itself, and opposite of ln, looking at the calculator, opposite of ln is e, so e to the 1. So on my calculator, I'm figuring out, so I'm doing second function ln, so that's e to the power of 1. And I'm getting 2.7 rounded off, 2.72. And that makes sense. 2.72, that looks about right.